Have you ever just stared at the sparkle inside a diamond? Or maybe wondered how a tiny little cable can carry, the entire internet? Well, it's not magic, it's physics. So, let's dive in and uncover the secret behind one of light's most beautiful and, frankly, most powerful tricks. So, it really all starts with this one question. We see this incredible sparkle, this fire that just seems to erupt from inside the stone. But how? What is actually happening to the light that goes into a diamond to make it dance like that? The answer has this amazing, almost dramatic name: total internal reflection. I know, it sounds a little complicated, but trust me, by the end of this, you're going to understand exactly what it is, how it works, and why it's responsible for so much of the cool stuff around us. Okay, so to get to the total reflection part, we actually have to back up for a second. We first need to get a handle on a more basic behavior of light, the simple rules of how it bends. This bending has a name. It's called refraction. And you have seen this a million times, I promise. Just think about a pencil or a straw in a glass of water, how it looks kind of broken at the surface. Yeah, that's refraction. It happens simply because light changes speed when it moves from one thing, like air, into another, like water. And that change of speed literally forces it to take a little turn. All right, so there are two key rules here. When light goes from something less dense to more dense, say from air into water, it slows down and it bends towards an imaginary line we call the normal. But, and this is the important one for us, when light tries to go from a denser thing back to a rarer one, like from water back out into the air, it speeds up and bends away from that line. That second rule, that's the key to this whole mystery. So let's really focus on that second rule. What happens when light is already inside something dense and it's trying to make a great escape back out into the open? So, picture this. We're at the bottom of a swimming pool with a flashlight and we're pointing it up towards the surface. Let's watch what happens to that beam of light as we start changing the angle, as it tries to escape the water and get back into the air. Okay, check this out. At a small angle, no problem. The light ray gets out, bending away from the normal just like we expected. Now, as we increase that angle, you can see it bends even further away. It's having a harder time getting out. And then we hit this very specific, very special angle where the light bends so much that it can't really escape at all. It just skims right along the surface, perfectly flat at 90 degrees. This moment, this right here, is the point of no return. The light has reached the absolute limit for its escape plan. Any steeper, and it's not getting out. So, what do we call this special angle? Well, it's called the critical angle. It's that one precise angle of approach where the escaping light ray is forced to bend a perfect 90 degrees, just skimming the boundary. It is the last possible chance for refraction. So, what do you think happens if we push that angle just a tiny bit further? And there it is. Total internal reflection. If that angle is even a fraction of a degree greater than the critical angle, escape is impossible. The light can't get out. Instead, that surface, that boundary between water and air, suddenly acts like a perfect mirror, and 100% of the light is reflected right back down. It's trapped. Now, this fail escape isn't a failure at all. It's actually the secret ingredient behind some of the most amazing things in both nature and technology. So let's bring this all the way back to where we started. That intense sparkle of a diamond, that's just light getting trapped inside, bouncing around over and over again because of total internal reflection, before it finally finds a way to shoot out the top. Those fiber optic cables that power our world, they're basically light pipes, using this exact principle to keep the signal bouncing perfectly along the inside of a tiny glass fiber for thousands of miles. Even the incredible beauty of a rainbow depends on this. And this chart really shows you why diamonds are so special. Look at that critical angle. A diamond's is only 24.4 degrees. That is tiny compared to water or even glass. What that means is that it is incredibly easy to trap light inside a diamond. Almost any light that goes in gets bounced around internally over and over before it can escape, creating that dazzling, fiery sparkle that we love so much. So to recap, there are really just two simple rules you need for this magic to happen. That's it. First, the light has to be trying to go from a denser material into a rarer one. And second, it has to hit that boundary at an angle that's greater than that material's special critical angle. You get those two things and you get total internal reflection. That's the whole secret. Which brings us to a final thought. We know light gets trapped inside a diamond to make it sparkle, but light also gets trapped inside countless little raindrops in the sky. So the next time you see a rainbow, think about it. You now know exactly how that same principle, total internal reflection, is working inside millions of tiny water droplets to create that spectacular arc of color across the sky.